Okay, good morning. Hopefully, you were able to have some success working on the first set of practice problems that I had posted. I want to work through each of those problems individually so I can hopefully answer any questions that you might have had in completing the practice problems. If I don't cover something that you still have a question, as always, feel free to email me at mymccall@sasd.k12.pa.us. Okay, so I am going to do my best to write on my iPad and project that onto my laptop so you guys can see how I'm going to solve each one of these problems. So the first problem I had asked you to try was log base 4 of 16 equals 2. So you can see I wrote that right here. Now, the first four problems that I wanted you to work on were problems where you had to take them from logarithmic form and simply put them into exponential form, which is what the directions say. Write the logarithmic equation in exponential form, and it gives you an example right here to follow. So let's take this one. I'd like to key in on the base of the log. Here, the base of the log is base 4. That is going to translate into becoming the base of our power. So that's going to be 4. And then the other two numbers essentially switch. So it becomes 4 to the second power equals 16. It's not easy. There's the first one. Okay. The next problem I asked you to do was number 8, and that was log base 9 of 1 over 81, and that equals -2. So we have log base 9 of 1 over 81 equals -2. Once again, key in on the base of the log. Here, the base of the log is 9, so that becomes the base of your exponent. 9 to the -2 power is equal to 1 over 81, and that's your exponential form. The next problem that you needed to complete was log base 32 of 4 equals 2/5. Key in on the base of the log, that's 32. So that's going to become our base of our exponent, 32 to the 2/5 power is equal to 4. The last one from that set is going to be log base 64 of 8 equals 1/2. Log base 64 of 8 equals 1/2. So the 64 is the base of our power. The 1/2 goes up here, and then the 8 goes over here. Keep in mind, the 1/2 power is exactly the same as the square root. So the square root of 64 is indeed 8. Okay, so those are the first four problems from the practice problems that I wanted you to work on. The next four problems, 11 through 14, were essentially the same. However, rather than going from logarithmic form to exponential form, they have you going from exponential form to logarithmic form. So it's the exact opposite of what you just got done doing. So the first problem was 5 to the third power equals 125. The next one after that we're going to do, I'm going to write two down at a time, it's going to be 9 to the 3/2 equals 27. Okay, so there we go. There's the next two problems we're going to work on. So these are both in exponential form, you can tell because they have an exponent. So we want to key in on that exponent, actually look at the base. The base in this problem is 5. Therefore, that's going to become the base of our log. So we're going to have log base 5. And then the next two numbers just simply switch. The 125 goes here, and then that equals 3. This one, 9's our base, so it becomes log base 9 of 27 equals 3 over 2. All of these problems that I've done, the first 6 problems, are utilizing that very first rule, and in my opinion, is the most important rule, which is how to change from logarithmic form to exponential form. The last 2 problems from this set are going to be 4 to the negative 3 equals 1 over 64, and then we're going to have 24 to the 0 power equals 1. This one, 4 is the base, so that becomes log base 4, and then we have 1 over 64 equals negative 3, and this is log, again, 24 is the base, so log base 24 of 1 equals 0. All right, so that finishes up the problems from the first 2 sections. The last 4 that I ask you to do, it says in exercises 15 through 20, they want you to evaluate the function at the indicated value of x without using a calculator. So this can be a little bit tricky, but hopefully you'll catch on. So the first thing I want you to see here is we have f of x equals log base 2 of x. We are going to substitute 64 in for x. So our problem is going to be f of x equals log base 2 of 64. I'm going to switch you over there now. Okay, so I don't like leaving it as f of x. I think f of x is cumbersome to continue writing over and over again, especially when you have to take it from logarithmic form, which is what we have, into exponential. So I like to always substitute y in for f of x, just for a little bit of easier notation. So key in on the base of the log. The base of the log is 2, so 2 is going to become the base of the exponent. 2 and then the 64 and the y switch. So it becomes 2 to the y equals 64. Now, this is going to be a little bit tricky for you to know, but 2 to the y is not going to change, but 64 is a power of 2, and it is actually 2 to the 6th power. Now you can see that we have the bases of 2 are matching, so we can simply write y is equal to 6. And that's your solution for the first one. The next one is going to be f of x equals log base 25 of x, where x is 5. Now, I'm going to substitute the 5 in for the x right away. I'm also going to make this y equals rather than f of x equals. So we have y equals log of 25. Sorry, I said that wrong. It's log base 25 of 5. So this is again logarithmic form. We want to write it into exponential form. So the base of the log is 25. Therefore, that becomes the base of our exponent. And the 5 and the y switch, and we get that. Now this one's going to take a little bit of manipulation before we can actually solve for y. First thing to notice is this is 5 to the first power. Now, the 25 and the 5 are not matching, so we need to make that happen. 25 is actually 5 squared. And then we still have 5 to the first power right there. Now you can see how I rewrote 25 as 5 squared. Now we have a power to a power. Anytime you have a power to a power, you simply multiply. So you get 5 to the 2y is equal to 5 to the first. And now that we have the basis matching, we can set 2y equal to 1, and we divide both sides by 2, y equals 1/2. Okay, the next one, 2 more to go, is f of x equals log base 8 of 1. So we're going to key in on the base. This is 8 to the y equals 1. Now, this is one of the knowledge-based questions that we covered, and it is one of your log properties as well. But anytime you log 1, the answer is going to be 0. But if you're not sure about this, it did ask you put this into exponential form. 8 to what power is 1? Again, this is kind of a knowledge-based question. You need to remember that anything to the 0 power is 1. So if I substitute 0 right in for y, you would have 8 to the 0 power, which is 1. Okay, the last problem that you were asked to complete is f of x equals log of 10. So f of x equals log of 10. Now, that problem is a little tricky if you don't remember that anytime there is no base written, I'm going to circle right there. If there's no base right there, that means that it is actually base 10. And this falls back on one of the properties that we had, where when the base of the number matches the number that is being logged, the answer is going to be 1. Now, another way to think of that is to take that and put it into exponential form. So if I take the base of the log and I set it to the y power, that's equal to 10. Well, that 10 is 10 to the first power, and you can see y is 1. And that's exactly what I said it was going to be up there based on your log properties. All right, there you go. Those were the problems I asked you to complete. Hope you guys are doing well. Have a good day.